Suppose that we have a small open economy. In this small open economy, they produce only two goods, hamburgers and brownies. The opportunity cost of producing hamburgers in terms of brownies is 1, but in the rest of the world, the relative price of hamburgers in terms of brownies is 2. So the relative price of producing hamburgers in terms of brownies is greater than the opportunity cost in this small open economy. This small open economy has comparative advantage in producing hamburgers. And the question is, who benefits from the trade? So if this small open economy has comparative advantage in producing hamburgers, it produces only hamburgers. And the budget constraint, the slope of the budget constraint is greater than the slope of the production possibilities frontier. To determine the consumption point, we need an indifference curve that is tangent to the budget constraint. For example, this is the indifference curve that is tangent to the budget constraint. This is the tangency point. This is the new consumption point. Consumption point and this was the production point. The original question was, who benefits from trade? First answer, the consumers. This is the new consumption point. This was the original consumption point in a closed economy. Since this new consumption point is on an indifference curve that represents a higher utility, there is an increase in the consumer's utility. So, who benefits from free trade? The first answer, the consumers. There is an increase in the consumer's utility. Consumers. But what about the real GDP? Suppose that in this economy we have a statistical office, and the statistical office computes the price level as follows: px raised to power of gamma times py raised to power of 1 minus gamma. In this case, the real GDP can be determined by using the following formula. Real GDP equals px over py raised to power of 1 minus gamma, px over py raised to power of 1 minus gamma multiplied by the qx plus py over px raised to power of gamma, py over px raised to power of gamma multiplied by qy. In a closed economy, the qx and the qy is always on the production possibilities frontier function. And the production possibilities frontier function can be given by the following expression. L equals, where L is the labor supply, AX times QX plus AY times QY. So in a closed economy, we can express the qy from this production possibilities frontier function and then plug the expression for the qy into the real GDP. Let's see what happens. Qy from the production possibilities frontier function equals L over AY minus AX over AY times Qx. And then we plug this Qx into the real GDP expression. So the real GDP for a closed economy equals Px over Py raised to power of 1 minus gamma times Qx plus Py over Px raised to power of gamma multiplied by the expression for the Qy. And the expression for the Qy is L over Ay minus Ax over Ay times Qx. Of course, we can simplify this expression. Px over Py raised to power of 1 minus gamma times Qx plus Py over Px raised to power of gamma times L over Ay, the first part of the expression in the parentheses, L over Ay minus Py over Px raised to power of gamma times Ax over Ay multiplied by the Qx. In a closed economy, we know that the Px over Py, so the relative price, equals the ratio of the unit labor requirements. Px over Py equals Ax over Ay. So this Px over Py is Ax over Ay. This Py over Px is Ay over Ax. This Py over Px is Ay over Ax again. And we can use this knowledge. So the real GDP for a closed economy, Ax over Ay raised to power of 1 minus gamma times Qx plus Ay over Ax raised to power of gamma times L over Ay minus Ay over Ax again raised to power of gamma multiplied by Ax over Ay multiplied by Qx. But this Ay over Ax raised to power of gamma is Ax over Ay raised to power of minus gamma. And if we multiply this Ax over Ay raised to power of minus gamma by Ax over Ay, we are going to get Ax over Ay raised to power of 1 minus gamma. So these two together is 1 minus gamma. The exponent is 1 minus gamma. So the real GDP for a closed economy, Ax over Ay raised to power of 1 minus gamma times Qx plus Ay over Ax raised to power of gamma times L over Ay minus Ax over Ay raised to power of 1 minus gamma times Qx. But we have Ax over Ay raised to power 1 minus gamma times Qx, this part of the expression, with a plus sign, and Ax over Ay, 1 minus gamma times Qx with a minus sign. And this part eliminates this part, so the real GDP for a closed economy is just this part of the expression. Real GDP for a closed economy real GDP for a closed economy is AY over AX raised to power of gamma times L over AY. This is the real GDP for a closed economy. But we have an open economy, a small open economy, and this small open economy has comparative advantage in producing hamburgers, in producing eggs. What is the real GDP for a small open economy? For a small open economy, the real GDP can be calculated by the general expression, so it's px over py raised to power of 1 minus gamma times qx plus py over px raised to power of gamma times qy. But this qy is 0, since if we have comparative advantage in producing hamburgers, we do not produce any brownies. Qy is 0. And we use all of our resources to produce hamburgers, so Qx is L over Ax. And Px over Py is the world relative price, so Px over Py is Px from the world over Py from the world. Let's use this knowledge. So this real GDP is Px over Py and world relative price raised to power 1 minus gamma times L over Ax. This is the real GDP for a small open economy. Which one is the bigger? The real GDP for a closed economy or the real GDP for an open economy? Let's see. So the real GDP for a closed economy was Ax over Ay raised to power of minus gamma times L over Ay. The real GDP for a small open economy is this expression Px over Py from the word raised to power 1 minus gamma times L over Ax. Which one is the bigger? Okay, let's see this expression. We have the labor supply in the right-hand side of the equation and the left-hand side of the equation. So this L eliminates this L, 1. And if we multiply the left-hand side of the equation by Ax and divide the left-hand side of the equation by Ax, so we multiplied the left-hand side of the equation by 1, then we get the following. Ax over Ay times 1 over Ax multiplied by the Ax over Ay raised to power of minus gamma. So this is Ax over Ay raised to power of minus gamma times Ax over Ay times 1 over Ax. But Ax over Ay raised to power of minus gamma times Ax over Ay is Ax over Ay raised to power of 1 minus gamma. So the left-hand side of the equation looks like this. Ax over Ay raised to power of 1 minus gamma times 1 over Ax. And this can be bigger, equal to, or smaller than the right-hand side of the equation. Px over Py from the word raised to power of 1 minus gamma times 1 over Ax. We have 1 over ax on the right hand side of the equation and 1 over ax on the left hand side of the equation. This 1 over ax eliminates this 1 over ax. So if ax over ay is higher than the px over py, then the left hand side of the equation is the bigger. If px over py is greater than the ax over ay, then the right hand side of the equation is the bigger. If ax over ay equals px over py, then the right hand side equals the left hand side. Which one is the true? Since we have a small open economy and this small open economy has comparative advantage in producing x, then ax over ay is smaller than the px over py. So the relative price in the world, in the rest of the world. And since the px over py is bigger than the ax over ay, the right-hand side of the equation is bigger than the left-hand side of the equation. The real GDP for a small open economy is bigger than the real GDP for a closed economy. Who benefits from free trade? Second answer. The whole economy benefits from free trade. If free trade is based on comparative advantage, there is an increase in the real GDP. Whole economy. There is an increase in the real GDP. And let's focus on the real wage. The general formula for the real wage was the following: px over py raised to power of 1 minus gamma times 1 over ax. In a closed economy, this px over py equals ax over ay. So this is ax over ay raised to power of 1 minus gamma times 1 over ax. In a small open economy, the px over py is the relative world price. So px from the world over py from the world. Px world over py world raised to power 1 minus gamma times 1 over ax. Which one is greater? The small open economy's real wage is greater, since the ax over ay is smaller than the px over py. So who benefits from the free trade? Everyone in this economy benefits. Every single individual in this economy benefits from the free trade. The third answer to the original question: everyone. So our main conclusion: if free trade is based on comparative advantage, then everyone in this economy benefits from free trade. Free trade is good for the consumers. There is an increase in the utility of the consumers. Free trade is good for the whole economy. There is an increase in the real GDP, and free trade is good for every single individual. There is an increase in their real wage. Free trade is good, period.